All right, so this is 4.1, part 2. All right, so we're going to talk about linear and angular speed. So we talked about our arc length formula on the first part. All right, so we talked about arc length. Our arc length formula is this. So S is our arc length. So S is equal to R times theta, where R is our radius and theta is the central angle. When we use this formula, theta has to be measured in radians. This is super important. It'll give you a theta in degrees just to try to trick you, but you have to convert it to radians because whenever you use this formula, it has to be in radians. So in example 5, we want to find the arc length. So our arc length is equal to, S is equal to R times theta. So we're trying to find the arc length S. What's our R? Radius, which is what? 4. And then what's our theta? 240, but we said our theta has to be in radians, so we have to convert it. How do I convert 240 degrees to radians? Multiply by pi over 180. So we can simplify this. 6 goes into 24 and 18, so it would be 4 pi over 3. Yeah. And then we plug it in. So I have S is equal to 4 times 4 pi over 3. So that gives us 16 pi over 3. You can just leave it as a fraction. You will not get a calculator for the next quiz and test. So we would just leave it like this. All right, next, we can find the linear speed and angular speed. So our linear speed is S divided by t, so our arc length divided by time. Most of the time we won't be given the arc length, we'll have to find it. And just like we saw on the last page, S is R times theta, so it'd be R times theta divided by t. So these being the same thing. So that's how we would find the linear speed. Then to find the angular speed, it would just be theta divided by time. The linear speed measures how fast the particle moves, and the angular speed measures how fast the angle changes. So a specific type of question that we can find the linear speed or angular speed would be questions involving clocks, because the angle changes, it's moving. This says the second hand of a clock is 10.2 centimeters long, as shown in figure 4.11. Find the linear speed of the tip of the second hand. So it's important to know some facts about a clock and a circle in particular. If I had a clock and I was just looking at this part of the clock, that would be a fourth of the clock, or we would say 1/4. If I had a circle, how many degrees would just be in 1/4 of it? 90 degrees, which would be how many radians? Pi over 2 radians. And then how many seconds would just 1/4 of a clock be? 15 seconds, perfect. If I had half of a clock, that would be half. How many degrees? 180. How many radians? Pi. And then how many seconds? 30 seconds. Let's say I had 3/4. This would be 3/4 or 3/4. How many degrees? 270. How many radians? 3 pi over 2. And how many seconds? 45 seconds. And then the last one would be the whole thing. So this would be a full rotation. How many degrees? 360. How many radians? 2 pi. And how many seconds? 60 seconds. All right, so for this question, it doesn't say specifically, but we're just going to use the full rotation. So to find the linear speed, what's our formula? R times theta divided by t. So it's S over t, but S is R times theta. What is my radius? 10.2. What is theta? If I'm doing a full rotation, what's theta? 2 pi. Remember, it has to be in radians, so it'd be 2 pi. And what is time? If my full rotation? 60 seconds. So let's plug this all in. So I would have 10.2 times 2 pi over 60. So when we multiply the top together, it'd be 20.4 times pi over 60. When we put it in the calculator, it's about 1.068. What would our unit be? 1.068 what? What's my radius measured in? Centimeters. And then what was the time measured in? Seconds. So it'd be 1.068 centimeters per second. That is my linear speed. It will either tell you, or let's try half. So let's say this said in half a revolution around the clock. So my radius would still be 10.2. What would my theta be now if I had half? Just pi. And what's the time? 30 seconds. So this would be 10.2 times pi over 30. When you put this into the calculator, you end up getting 1.068 again. It'd be centimeters per second. So for clock questions, it doesn't specify on like if it's a full revolution around the circle or half, because does your second hand ever speed up in a clock? Nope. So it's always like the same speed. So it doesn't matter which one you use. But if it's something other than a clock, it would specify and either say like a quarter rotation or a half a revolution or something like that.